Position and reference frames. Speed, distance, and time, the quantities that we've already defined, didn't require us to say where we started and where we ended up. They just measured how far we traveled and how long it took to get there. However, much of physics is based upon knowing where something is and how its position changes with time. Now, to define position, which is a new term we're talking about, we have to have a reference frame. And we'll talk about what that is next. A reference frame, right over here, lets us define where an object is located, and we describe it relative to other objects. So the key word here is relative to other objects. For example, we can use a map to compare the location of different cities. We can see, for example, New York City is east of San Francisco. Or different continents. For example, up here we have China, and here we have Australia. So we can say Australia is south of China. However, not every reference frame is appropriate for every problem. Let's try an exercise to see if we can come up with what a reference frame is. First of all, we'll need a volunteer who will have to leave the classroom to wait for further instructions. Okay, now we're going to place an object somewhere in your classroom. We need the team to write specific directions for that person who left to be able to come in and locate the object. You have to write them in such a way that you can hand them, right over here, hand them to that person. They can then follow the directions to the object. However, a couple more rules. You can't tell them where it's near. You can just say how they have to move to get to it. For example, walk to the smartboard is not a specific direction. So then bring your classmate back in, give them the sheet of directions, and ask them to find the object. After your classmate came back in, we're now going to reflect on what occurred. So go back into your groups, right over here, and make a list of the things you needed that worked, that were good with the directions that helped your classmate locate where the object was. Be sure to include that person in your discussion, of course. Then as a class, discuss your findings. As part of your discussion, hopefully you found out that you needed the following things. 1. You needed to tell the person where to start. You needed a starting point, and probably that was the opening to your classroom. Second, you needed a set of directions. For example, you could have told the student to go left. You could have told them to go forward, backward, up, down, right, many different ways to talk about directions. And third, you needed a unit of measure. We talked earlier in the chapter about how we're going to use meters for distance. Perhaps in this case, your unit of measure might have been a step, couple steps, a pace. Or you could have said walk 10 meters, and hopefully they had a meter stick to use. Now here's what we're going to use to do physics. You can see we have a coordinate system. We call this an X, Y, Z coordinate system. Z, this looks a little tricky because it's at an angle. What we really mean here is Z is coming out of the board towards you. It's kind of a three-dimensional reference frame. It's hard to draw in 2 dimensions, which is why we draw it at this angle. So we're going to call the origin 0. Right at the 0 point, there's the origin. We have 3 perpendicular axes, X, Y, and then Z coming out of the board. And of course, we're going to use the meter as our measure. We're not going to use footsteps or paces or anything else like that. For this course, for this algebra-based physics course, we're only going to be solving problems in 1 dimension. Typically, we're going to use the x-axis, the horizontal axis. Plus x, over here, positive x will be defined as to the right. Negative x is going to be defined as to the left, just like the number lines you did in grade school. We could absolutely define it any way you want, but we're going to agree to use this convention. Positive is to the right, and left is negative. Also, we could pretend we had a compass here. And if we had a compass, north would be positive, south would be negative, or east, which is to the right, would be positive, and west would be negative. The symbol for position is going to be x. Later on in physics, when you do 2 and even 3 dimensions, then we will use y and z. But for now, we just need to use x.